All right, guys, I'm just going to go over this check-in for 424. Okay, and here you were given like a couple multiple choice. First one, you had this integral from a to b of f of x, and it gave you a value of a plus 2b, and then they want you to find this here, f of x plus 3, and see what you get. So what you should have done, break up the integrals. We already know this one's equal to a plus 2b. This is going to be 3x, but then you're plugging in b and a. So here you should get negative 2a plus 5b. All right, on this one you were making integral. So again, anytime you see this, that's like your change of x, right? So 0 to 20, okay? Because they are plugging in like 1, 2, 3, 4. No, my bad. That's how many rectangles they're going to be. Sorry, 0 to 1, because this value right here is equal to 1. And you can see there's just starting at 1 over 20 and going on and on and on. Our function is root x dx. Okay, I know that's a little confusing, but this really just tells you the change of x for your rectangles. So you can see 1, 2, 3 all the way up to 20. Since that last value is 1, you could write it this way as 1 to 0 root x dx. This one, so because the function is x squared, you can see everything is going to be above the x-axis no matter where you draw and are looking for the integral, right? So here k, the only number that it could be would be at 2 itself, because you don't have anything below the x-axis. It would have been different if it was, say, x cubed, right? Because this one you could have 2 values, right? So say you had it from 2, what's going to be similar, right, or the same in the negative direction would be negative 2. So this one k could be both, but in the one I gave you, it could only be that one value there. And the last. Okay, so they're giving you a right triangle. All of it is changing, so when all the sides are changing, you know you're going to use like the x squared plus y squared equals z squared. Nothing is constant, right? If you take the derivative with respect to time, 2x dx dt plus 2y dy dt equals 2z dz dt, right? You can see all the 2's will cancel, right? We have okay, so that's what you're taking the derivative of, right? And then the only other thing here is the instant that you have x to be 4, y to be 3, use Pythagorean theorems, you get z to be 5. And now you could plug in everything that we know, okay? So z is 5, dz dt was 1, right? We have x to be 4. I'm going to use this where I'm changing dx dt to 3 dy dt. And y was 3. This way I could solve for dy dt and then plug back in and get dx dt. So here I get 12 dy dt plus 3 dy dt equals 5, so 15 dy dt equals 5, so dy dt equals 1/3. So we were looking for dx dt, which I'm just going to plug into here, which is 3 times the dy dt, which is 1/3, and that gives me 1. So that would be your answer there.